a time when the world feels vast and slow. The Industrial Revolution is changing everything. Trains rumble across continents. Factories belch smoke into the sky, and cities swell with people. But much of life still moves at the pace of the horse and the sail. Gas lamps glow in streets at night, and candlelight flickers in homes. The stars, unpolluted by the glare of electric lights, shine sharp and clear above. People glance up and feel they understand the heavens, predictable, eternal, reassuring. Then one late summer day, the sun begins to hum with a strange intensity, though no one on Earth notices. A massive, unseen drama is unfolding 93 million miles away. This is the Carrington Event, though no one yet knows its name. The eruption is a coronal mass ejection, ACME, the largest such solar storm in recorded history. On the morning of September 1st, 1859, British astronomer Richard Carrington is at his telescope, studying sunspots. Suddenly, he sees a brilliant flash of white light erupt from one of them. For a moment, it's as though the sun itself has blinked, sending a pulse across the void. Carrington records what he sees, not realizing that this flare will become his legacy, and will soon change life on Earth for days to come. The pulse of charged particles races toward our planet, far faster than normal, arriving in just 17 hours instead of the usual multi-day journey. Earth's magnetic field braces for impact. That night, the sky ignites. The auroras, usually confined to polar regions, burst into view far closer to the equator. Curtains of green, red, and purple light shimmer across the horizon in places that have never seen such sights. In Havana, Cuba, farmers stop working to stare. In Hawaii, fishermen watch glowing waves beneath a swirling, colorful sky. In the Rocky Mountains, gold miners awaken in the middle of the night, thinking it's dawn because the light is so bright they can see their own shadows. In the American South, people look up in awe and fear. The sky looks aflame, as if the world has caught fire. And then, something even stranger happens. Telegraph operators across Europe and North America find their equipment crackling with static. Operators are shocked. Literally, in some places, the systems continue to send messages even after being disconnected from their batteries, powered solely by the currents induced by the storm. Imagine the confusion. Technology behaving as if alive, refusing to stop, whispering electric words without human command. The news spreads quickly. The sun has done something to the world. The auroras fade and return, sweeping like ghostly tides across the planet. Navigational compasses swing wildly, pointing nowhere reliable. In an age when ships depend on those compasses for safe passage, the disruption is dangerous. Messages are delayed or garbled. And yet, outside the telegraph offices and scientific circles, many people have no idea what's truly happening. In some towns, church bells ring as congregations gather, fearing the end times. In others, lovers take advantage of the otherworldly glow to walk at night, feeling they are in a dream. By mid-September, the storm has passed. Telegraph lines return to normal. The skies go dark again, save for the usual constellations. But in the minds of those who saw it, the event is unforgettable. Slowly, the understanding grows. The sun is not a constant, unchanging lamp in the sky, but a living, restless star capable of lashing out across the void. Now, imagine if something like the Carrington Event happened today. Our world is no longer lit by candles and powered by steam. Our cities and lives run on electricity, on a global nervous system of wires, satellites, and microchips, undersea cables linking nations, satellites orbiting above carrying billions of signals every second. And all of it is vulnerable to the same kind of solar storm, only now the consequences would be far greater. In a modern Carrington-level event, the first sign might come from satellites detecting a surge of radiation, the solar flare, followed by a warning of an incoming CM. Power companies could try to shut down parts of the grid to protect transformers from overload. Airlines might reroute flights away from polar routes where radiation levels could spike. Astronauts aboard the International Space Station might retreat to shielded areas. But despite precautions, the sheer power of the incoming particles could overwhelm systems. Satellites could be damaged or destroyed, disrupting GPS navigation, weather forecasts, and global communications. Internet traffic could slow to a crawl as data routes fail. Without refrigeration, food supplies in cities might spoil within days. Water systems relying on electric power might fail, leaving millions without clean drinking water. The storm's reach would be global, and in our interconnected world, its impact would ripple like falling dominoes. Some scientists estimate that a Carrington-scale event today could cause trillions of dollars in damage, with recovery taking years. Banking systems might freeze, all from a storm we could not see until it was already on its way. And yet there's a strange beauty to the thought that our fate is still tied so intimately to the moods of the sun that this glowing giant in the sky can, in a matter of hours, remind us of our fragility. The auroras would still come, sweeping across skies where billions might see them for the first time, painting the night in colors that defy imagination. There would be wonder as well as fear, connection as well as chaos. The Carrington Event of 1859 is a reminder of how small we are in the face of cosmic forces, and how quickly the everyday can be transformed. It happened once, in a quieter world, and we survived. Someday, it may happen again, in a world far noisier, faster, and more fragile. And when it does, perhaps we will look up, see the sky aflame, and remember that this has happened before, that we, too, are part of a universe that is alive, restless, and full of surprises.